Let's now mark as many of the points as we can. Your two vertices are going to be located at, because they're lined up vertically, they're going to have the same x-coordinate as the center, 1, and the y value is going to be plus or minus the a. We went up or down by 1.5. And your foci are going to be lined up with your vertices, so they'll also have an x-coordinate of 1, and starting from the center, minus 2, plus or minus the c value, 6.184. They're not marked on the graph yet, so I'm going to put them on there. Starting from here, going up 1, 2, 3, 4, 5, 6, and just a little bit farther. Starting from the center and going down 1, 2, 3, 4, 5, 6, and just a little bit farther. And there's one focus, and there's the other focus. Another thing that you might be asked, for the equations of the asymptotes, and the slope of this line will be given by your a's and your b's. You'll notice the line goes through the center, and this distance right here, so from here to here, which was the b, will be your run, and this distance from here to here, which in this problem was the a, will be your rise. So a is the rise, and b is the run. So the slope is rise over run, which will be 1.5 over 6. And this is equivalent to 1 over 4. To get the full equation, you can use the point slope formula. Y minus y1 is mx minus x1. If we use the center, well, any point on the line will do, so we'll use the center. Y minus negative 2, okay, which would be plus 2, equals 1/4 x minus 1. And this one has a slope of 1/4, but this one over here, the slope is negative 1/4. So we might get both at once by writing y plus 2 is equal to plus or minus 1/4 x minus 1, and bring the 2 to the other side. 2 plus or minus 1/4 x minus 1 gives you the equations of both lines, both asymptotes. The only other thing I can think of is eccentricity, which is given by the letter E. Same as for an ellipse, it's C divided by A. So our C was 6.184 divided by 1.5, and I believe I've already got this one worked out as well. Approximately 4.12. Now the eccentricity is just a measure of how spread out the parabola is. So I forget which way it goes, but if it's higher or lower, it means it's either these forks of or these branches of the hyperbola are either more spread out or less spread out. You could learn that by experience by looking at eccentricity for various hyperbolas.